Okay, so terminal. Based on that title, I bet you might be thinking, hang on, are we doing Linux command line stuff? But we're not. We're gonna play a game. Or at least I'm gonna tell you about a game because it takes a while to play and I don't want this meeting to go for hours. So, you should go to this presentation for multiple reasons. One is for this list of links. Two is because there's a questions page below it, and you can send in your questions and I'll be able to see them. Three is because that's how we take attendance, and we like having an accurate attendance count. So that's at dsuprog.club, and then go to the Meetings tab and click on View Meeting for Terminal. So let's dive right in. So Terminal it's a programming game, and it's a whatever it's called. Already forgot the word. Tower defense game. And the way you play it is by writing an AI to play the game, and then you can either play against your own AI to figure out what its weaknesses are and then patch those weaknesses, or you can play your AI against other people and compete on a leaderboard or in competitions. And as you can see here, I thought this would take less time to load. As you can see here, the competitions can get pretty high value. So to start learning about what exactly this game is, let's dive into a game where I play by hand against an algorithm that Blake made and you'll have access to in the presentation links here. That's the starter kit. Let's start game. So on the left here, you've got the health and points of each player. And so this is a simultaneous turn-based game, so each player takes their turn at the same time, so they don't know what the other person is doing for that turn. So there's this board right here, and this is what it looks like when it's actually in a game. You can place different units on the board, and they go across and when they get across, they lower your opponent's health. And so so over here in the game reference, you have the mobile units, which are the attackers, and those can only be placed along the very back edge. And then they move across zigzag style unless they're blocked by a unit. And they do different things based on what they are. Well, they move differently based on what they are. They all do basically the same thing. You've got the scout, which is really cheap and low stats, but it's also really fast, so it can just kind of zip on past some things and sneak in a point if you can get past their defenses. You've got the demolisher, which is more expensive, but it has better stats except for its health. And so it does a decent amount of damage to the opponent's structures. And then you have the Interceptor, which seems, based on just these stats, like it would be objectively better than the Scout, except for speed, which is the slowest speed, because the speed number here is represented as the amount of frames that it takes for it to move one space. But the trick with the Interceptor is that it cannot attack the enemy structures. So it has a high damage, but it won't be using that against the structures that the enemy places. It'll only use that against your opponent's health directly. Or against against attackers. So then you have the defenders, and the defenders can be placed anywhere along your half of the board. And they do what it says on the tin, they defend. There are 3 types of these also. There's the wall, which is cheap, and it just kind of pushes the enemy out of the way, basically. It makes it so they can't move past that space. You've got the factory, which costs a lot, because when they originally made it, they realized that it was kind of overpowered, so they had to nerf it by increasing the cost a lot. And that generates 1 mobile point at the start of each turn, and the mobile points are what you use to place your attackers. That's the cost of these. And then the turret is a turret, so it just shoots things. And it has the highest health out of all of these. And it costs twice as much as a wall, but still quite a bit less than a factory. You can also upgrade the units, and the upgrades each have an individual cost, and they do different things based on what the unit is. And you can do that to units that you placed in a previous turn, and it costs structure points, which are what you use to place the defenses to. So the map here is based on a grid system, 0 to 27 in X and Y. And the reason those numbers are important are for when you're writing the actual code of what to do. You need to be able to say, I want to place something here if it's doing something over here or whatever. And so you gotta be able to recognize that that's 10, 10 or whatever over here. And it says, if I move this over here, it says over here what coordinate it's at when you're on here. So now if I go back down, so the turns are in 3 phases. The restore phase, where it just determines how many points you should have for the next turn. You lose mobile points in between turns, so it's harder to save those up. And then you also gain both mobile points and structure points each turn. Then there's the deploy phase, where you can place your units. So that's what phase I'm in right now. And then when you click submit turn, or when both players have submitted their turns, it goes into this phase here, which I need to double check the name of real quick. The action phase. And this happens all on its own, even in regards to when you're programming it. You don't have any influence over the actual action phase. The entirety of the game is played in the deploy phase. And then the action phase is just based on where all of the units are deployed to. And so here, you've got these units here and here, and these are the only mobile units. So they just move forward until they're within range of each other and then attack and kill each other. But if they had gotten to the other side, that would have decreased the opponent's health. So now, so an important note here is that the maximum turn count is 100. which seems like a lot, but this game is really meant to be played algorithm v algorithm, AI versus AI. The playing by hand modes are mostly just in there so that you can understand how the game works and then write an AI that plays it well. So it lasts to 100 rounds only if you can't get the opponent's health to 0 and they can't get your health to 0, so that it doesn't play infinitely if you have an algorithm against an algorithm where both the algorithms are like really good at defense and really bad at offense or something like that. And then the requirements for actually playing the game. It says it needs Google Chrome, but I used the latest version of Microsoft Edge and that worked for uploading your code. And then for actually programming it, the 3 languages you can use are Python, Java, and Rust. We really recommend Python because that's just the easiest to use, and they're all basically the same, or I should say, like, none of them are really similar to C, and more so than the others. Like, Python might be the easiest to learn going from C to a second language out of these. And if you're running it on Windows, you need to use PowerShell to run the commands. You don't use the command line. So when you're programming it, they have their starter kit, but it's pretty advanced, so Blake made his on GitHub and posted it to GitHub, I should say. So you can get either of those. The one that is, yeah, so both of them have documentation in the folder, so you can like know what all the functions are, which I won't show here because it's kind of a lot and that would take a while. But Blake will go over some very basic stuff towards the end. There are some tools here. The only one here that I really noticed as being good, or at least easy to figure out, is the Map Maker by Kevin Bow. If you click on Source here, and then click on the link here, it takes you to a recreation of the map, and then you can place things down, and then get the points that you placed them at for using in the code. And I believe this is using an outdated system for naming, so you would need to change that, but it's good for if you just want to create a position and then copy paste it in. At the bottom of here they have a whole bunch of stuff for if you're getting errors or don't know what to do. And then, yeah, so let's start actually playing a game here by hand against the starter kit AI. The strategy that I found in the forums is to place a whole bunch of factories so that you can just swarm them with mobile units. So I'll do that. And then I'll try to destroy this over here so that I can get stuff past them later. And then mostly I'll just place things arbitrarily because I don't really have a set strategy for this game yet. So this just keeps moving along. And it looks like it'll sneak on past these guys. And so now player 2's health just decreased by 1. And now it's the next turn. And I won't go into too many turns of this, just want to show it working, basically. So since this is a really simple AI that I'm playing against, it pretty much just places an enemy here and then has it go down here. And I think that's really enough of playing it. As I said earlier, there's competitions. There's also a forum, so if you want to like actually kind of get into the game more, you can read the forum for either strategies or just talking about the game. That's how I found the strategy for spamming the factories. And now I think Blake's gonna go over some of this code here, or here.
Yeah, so if you want to go back to the presentation. So I just took their starter kit, which wasn't very simple, and cut it down a lot to make a strategy that's really bad, but it's much easier to learn from it because you actually know what's going on. So the two functions I have on screen right now, this is written in Python, obviously. The top one is just a function that they provide that's run every time it's your turn. And the only purpose that that function really runs for us is that it runs the starter strategy function, which is right under that, which you can see calls two other functions called build defenses and build attack, which the build defenses is what places our structures, and the build attack is what places the mobile units. So if Nick, you want to go on. Now this is where the majority of your like actual programming will take place. So since you can't really program anything during when the engine is running your game, you just program what happens at the like start of your turn, the deploy phase. So you can see here we just list some turret locations, which is where the turrets were before in the game that Nick was playing, and you just called the attempt spawn. So every function in this is like attempt something. So if you don't have enough structure points to do this, it'll just spawn as many of them as it can. And the same thing for walls. This is their basic defense thing here. So you can see it places some turrets, then it puts walls in front of the turrets and tries to upgrade them. So you can protect the turret from ships like Nick was trying to do last game. You could see the turret kept killing his ships before they could destroy the wall. And then the attack function is the really simple attack function that Nick was talking about, where all it does is tries to spawn as many demolishers as it can on the same point. You see that 1,000 at the end is how many it tries to spawn. It just spawns as many as it can, basically, because you'll never be able to spawn that many at once. And this is actually it's most of the code that you actually need to deal with. The rest of the code is just set up for how Terminal runs the game. So it's all part of like a class that Terminal will handle in the back end. You just have to manage these. And you can do a lot more than what there is here. Like you can look at the spots that you were scored on, and then use those positions to put turrets near there, so you don't get repeatedly scored on in the same spot, which is what their starter kit example does, but I decided to cut it just to make it easier to understand. You can also like use different sorts of ships to like scout, and then once you've built up a bunch of mobile points and you're ready to go on the attack, you can just spawn a whole bunch, and you can do this all in code because you can look at what happened in the last game, what happened in previous games, how many points you have and all that, and set it up so you can win, I guess. if you look on the GitHub, which is in the links for this presentation, the only file you really need to deal with here is the algostrategy.py file. Nick, if you want to click into that. There you go. So you can see here, this is all that like extra stuff that I said you don't really need to worry about, that it will do for you. You can see there's the on turn function. So all it really does is start running our strategy, and then after that, it's our strategy just takes over. So if you'd like to like start using this, you can just clone this repo, edit this file, and then you can upload it straight to the terminal website. You don't have to deal with any of the local options for like testing your algorithms. And then you can just watch it run in real time. You can run it against any sort of algorithm that you want. You can even run it against itself to test how good it is. Well, in that case, it would probably not do anything interesting, because both of them would always do the exact same thing. But yeah, that's all there really is to start doing it. But there's a low floor for learning how to do it, but like a extremely high ceiling for mastering it. I mean, obviously, if there's competitions for $25,000, it must not be too easy to make really good algorithms or AIs to do it. So if you guys have any questions, just say them out loud, or we're on the questions page too. Alright, well, if you guys don't have questions, we don't have to keep you. But I think we're definitely going to do more with this in the future. I think it's a really cool way to learn a bunch of like niche programming like ideas and concepts. So definitely take a look sometime. But if nobody has any questions,
We did get a question. It's how much
yeah.
time does the algorithm get to execute?
So it does track time. I don't think it particularly matters. I mean, if your algorithm does like a lot every turn, I think they might just cut it or something. But usually your algorithm won't be large enough for it to really matter how much time that it takes. Because since you're not processing things during the game, you're just setting it up on your turn and letting it play. I think it's mostly fine with how much time it takes. And then obviously you only get 100 turns.
But it still needs to react to what the other person's doing, right?
Yeah. Well, it doesn't have to, but if you want a good algorithm, you probably should.
Got it.
And there's utilities inside of the library that it comes with to like get what happened the last round or previous rounds. And there's a more complicated thing that it runs every time an action happens, which couldn't be anything. So you can learn off of basically anything that happens. Like if you only dealt so much damage to something, you could learn off of that, and your algorithm could then plan on its next turn to fight off of that. You can take this so many different ways, which is why we think it's so cool.
I asked about that because chess engines work in such a way that they use as much time as possible before making their move. This might be
Yeah, I mean, I'm sure they would cut it at some point if it gets ridiculous. I don't know the exact time limit, but Yeah, that would be. It's probably that way to prevent you from doing actual machine learning. Well, not actual machine learning, but like more intense machine learning. Because if you could just run like a neural net and learn every time, train it, that would be kind of an OP strategy, and they want to prevent you from doing that as best they can.
It's only a question of how much I'm allowed to do.
Exactly. I mean, if you can time it, go for it. Well, if you guys don't have any more questions, we'll just call it there. So thanks for coming,